So let's say there's a reaction A plus B gives you C plus D. So it has a fixed rate, right? For example, let's say it will take 10 minutes to finish the reaction, right? But for example, if I want to change the rate, that means either I want to make the reactions fast or I want to change make the reaction slow. So what are the procedure I can follow? You know, how can I make a reaction fast or how can I make the reaction slow? The first one is by changing the concentration. What do you mean by concentration? Let's forget the C cup. Let's forget the C cup. Let's focus only on the A and B. Okay. Let's focus only on A and B. In A and B, which one is dilute? Which one is concentrated? So we know that A will be diluted.
Yeah, and
B will
be concentrated.
Okay. Now forget A. Let's concentrate only on B and C. When you concentrate only on B and C, you see that B has 3 cups of sugar and C has 5 cups of sugar. That means B will be diluted and C will be
concentrated.
So you see, B in the previous example, it was concentrated, but in this example, this is dilute.
Yes,
right?
sir.
So we can't see actually that which one is dilute, which one is concentrated. It's basically comparative. So you compare with something else and then decide whether it's dilute or concentrated.
Yes, sir.
Okay. But basically, in general, you should know that if it's if it's dilute, that means it's weak, and if it's concentrated, it is. If it's
strong, it's concentrated. If it's weak, it's diluted.
Yeah, exactly. So the first one is changing the concentration, right? So a reaction gets faster when the concentration of the reactant is increased. This means that you can slow a reaction that by reducing the concentration. That means, for example, if you have a reaction A plus B gives you C plus D. If you increase the concentration of this and this, so the reaction automatically gets faster. Okay. For example, you have Na plus NHCl, which gives you NaCl plus H2O. If you increase the, earlier you were having, let's say, a dilute HCl, you know, so the reaction took 5 minutes to get over. Now, if you took concentrated HCl, so reaction just might take 1 minute, you know, to complete it. So as you increase the concentration of the reactants, these are reactants, the reaction gets. The next thing is by changing the temperature. Now tell me one thing, when the temperature increases, the motion of the particles increases or decreases?
Increases,
right? So a reaction goes faster when the temperature is raised. As you increase the temperature, the molecules
reaction also increases. Molecules collide with each other fastly.
Yeah, exactly. Fastly, so the reaction gets faster, right?
Yeah.
It is generally observed that every time you increase the temperature by 10 degrees Celsius, the rate gets
double.
So every 10 minutes, if you every 10 degree, if you increase the temperature, the reaction rate becomes double.
Yeah.
That double now. So instead of 20 minutes, it just take 10 minutes, right?
Yeah.
And the reaction in 10 minutes will get over. I hope you're getting this.
Yeah.
Right?
Yes, sir.
The last point is by changing the surface area. What do you mean by that? This area of the reactants will be more. So there can be more places for reaction, right? Let's say in the first case, you have this much sodium, right? And you pour HCl over it. And you have this much sodium and you pour HCl over it. In where reaction will be faster?
Yes. A,
exactly. Why? Because the surface area is
less.
More. In A, the surface area is more.
Yeah.
Right? So higher.
B.
Yeah. So higher the surface area, faster is the
reaction.
Yeah. Okay. These are 3 things which can be used to change the reaction. First is changing the concentration. Remember, reaction
becomes faster.
Right.
So when we change it.
Yeah. in temperature, what happens? If you increase the temperature, reaction becomes
increases.
Also increases. And the third one is by changing surface area. So if you increase the surface area, reaction becomes
increases.
Did you understand this?
Yeah.
What's the explosion? Any idea?
A burst.
Yeah. So what happens? Any reaction when it is too fast, when it becomes the rate of reaction which was happening becomes too high. You know, when the reaction was supposed to have when it was too high, it generally leads to an explosion. Okay. So the reaction when can it be? When let's say the temperature is too high, when the concentration is too high, or when the surface area is too high. So what three methods we saw? If any one of them is too much, so then the reaction rate is very fast, and that's uncontrollable. We can't control that, and that leads to an explosion. Okay. Now, let's suppose. So here we'll be studying about what is a collision theory. So now, Mg plus 2 HCl will give you MgCl plus
HCl
2 plus H2. Okay. Now, in order for the magnesium and acid particles to react, the particles must collide with each other, right?
Yeah.
There will be some magnesium particle, there will be some HCl particles. They must collide with each other for the reaction to go ahead, right?
Yes, sir.
So this is the first condition, that the particles must collide with each other.
Yes,
and the second collision is the collision must have enough energy to be successful in order to, in other words, enough energy to break the bond to allow reaction to occur. Now, let me explain you this.
Yeah.
This is a very important issue.
Yes, sir.
Now, HCl will have some bond between them. Okay.
Covalent.
Exactly. So HCl has a covalent bond, right? So now let's suppose I add magnesium to it. Okay, right? So magnesium should go and break this bond and then react with Cl and form Mg
and
Cl2. And this H2, when breaks from Cl, will just go and liberate as H2.
H2.
Did you get this?
Yes, sir.
So magnesium should have that much power that it should break this bond, right? Yes. Otherwise, there will be no reaction because magnesium won't be able to break this bond. So magnesium can't go and join with chlorine, right?
Yes, sir.
So it just there are a few examples. Like, instead of magnesium, if you put copper there, I don't know if you know this. So copper plus HCl, what does it give?
Copper plus HCl, sir.
Yeah, it gives no reaction. Remember this.
Yeah, yeah.
Why? Because copper is not able to break this bond between H and C.
Yeah.
So there is no reaction basically between copper and chlorine. Okay. So that is what the collision theory second point said. That the collision must have enough energy.
To be successful.
Yeah, or in other words, enough energy to break
the
bonds to allow reaction to